All right, so next, example 2, the graph of a linear function is shown on the grid. Formulate an equation that represents the linear function. Now, you might get something like this. Let's do A first. Again, the first thing we want to identify is use rise over run to determine the slope. Okay, so if we were to do rise over run, I would just probably start with the lowest left, which is 0, and I would go up 20, 40. So our rise, so m equals 40, and then our run looks like it's just 20. So 40 over 20 is my slope, or, right, I could also write down m equals 2, because that would reduce to 2. After that, of course, we need to identify the y-intercept from the graph. And I can already look at this and see that we're crossing, so the y-axis at 0. And so this one's going to be pretty easy to write. You're going to have your y equals, your slope is 2, or you could put 40 over 20. That's fine too, x. And because our y-intercept is 0, we don't need to put anything. I wouldn't mark you down if you did a plus 0, but in reality, we could just leave it at y equals 2x. And you have your answer right there. Let's go ahead and look at this next one. Again, our first step is use rise over run to determine the slope. So let's go ahead and do that. Our slope, so m equals, let's see, if we're starting at 900, we're dropping 100, 200, 300, so negative 300 over, and then let's see, we dropped 1, 2, 3, and we go 5, 10, so over 10. Or again, you can also write this as negative 30, because that would reduce to negative 30. So our slope is negative 30. And then next, you're going to identify the y-intercept from the graph. And this one's also pretty easy because we can see that it's crossing at 900. So our y-intercept is 900. Now we come at our equation. You're going to have y equals, replace m with what you got for your slope, which is negative 30. Put x in there, and then plus 900, because b is your intercept. And there you go, you got your answer. Let's go ahead and go down and look at some example of word problems. So a newly opened candy store spent $22,500 on a refrigerated candy display. The store also spent $7,500 on candy making ingredients, rent, payroll, and other reoccurring expenses each month. So we're constantly paying that $7,500. And so if we're looking at this, write a function that shows the relationship between y, their store's expenses, and x, the time and months. Now, we already know we're going to have that y equals, and we already know we're going to have our x, and we're going to have some kind of plus or minus a number. Now, let's first identify what our reoccurring cost is. What are we constantly paying? What is that constant rate of change? And if you read it, it says that we're paying a constant rate of our ingredients, rent, payroll, and other reoccurring expenses. So 7,500 will be our y-intercept. And then our one-time fee of buying that refrigerator is 2,500, so that will be our y-intercept. And after that, we can now answer questions B. So using the function to determine how much the store will spend on its expenses by the end of its first year. Now, if you think about it, there's, we know that there is 12 months, so x is going to equal 12 because we know there's 12 months in a year, and we're looking at total costs after 1 year. So if we're looking at the equation 7,500 x plus 2,500, we're going to replace x with 12 plus 2,500. And then we can go ahead and solve that, and y is going to equal $92,500 in 1 year is how much you will spend on your company. So our final official answer would be the store will have $92,500 in expenses by the end of its first year. All right, Joel, that's it. You're going to now do practice A and practice, just practice A today. And then I might have you do practice B tomorrow. But today I'm just going to have you do practice A, go through these questions, answer them. If you need any help, let me know. Have a great day.